Hello MBA students. I am getting ready to show you how to do example 6.2 in your textbook. This is another example that deals with binary numbers in your optimization models. And so this one is going to deal with both a set of numbers that's binary and a set of decision variables that's not binary. So we're kind of mixing and matching here. So the first thing we're going to do is identify our decision variables. So there are two sets, as I previously mentioned. This first set is purchase equipment, and purchase equipment is going to be our binary set. You are either going to buy the equipment or you are not going to buy the equipment. Okay, there is no partials here. So we're going to identify that as a decision variable, and the other decision variable is how many units we produce on the equipment that we actually buy. So go ahead and mark that as another set of decision variables. All right, the first thing we are going to calculate is our logical upper limit. This is probably the hardest part of this particular problem, and so let me explain it to you as we go along. Well, first of all, if we don't buy any equipment, then we can't produce any of that. So if we don't buy the equipment to produce shirts, then we cannot produce shirts. Same with any of the other types of clothing items here. So we are going to start our formula with the equals, and so the first thing we're going to reference is our binary variable for the clothing item, and then we are going to multiply that by the rest of the problem. Again, same as last time, that's because if that binary variable is 0, then our logical upper limit is going to be 0, and it's not going to allow solver to plan for you to produce any items of clothing on equipment that you don't actually have. So the next thing we are going to do is we have to calculate the maximum number that we can produce if on that unit if it is bought. So if this is a 1, now we have to know what's the maximum number that we could produce. And I should warn you, I am home with a sick little boy today, so you may hear his sweet little voice on the recording, but we're trying to keep him distracted. Okay. The next part of our equation is going to be a min function, and we're going to calculate the number of labor hours available, and we're going to make that an absolute value so that we can copy and paste this formula. And then we're going to divide that by the number of labor hours it takes to produce 1 unit. And I'm sorry, you know what? That should not be a comma. It should be a divide. So it's D22, which is an absolute value, divided by B5. And that's going to give us the maximum number of shirts we could produce if that was the only thing we produced with this resource. The next thing we're going to do is cloth, and again that's going to be an absolute value, so that's the maximum cloth available, and we're going to divide that by the amount of cloth needed per unit. And so what this formula is going to do is it's going to pick the minimum of these, because it doesn't matter if you have extra labor hours if you're out of cloth or vice versa. So the maximum you can produce is going to be whichever one of these is smaller, because again you can have extra and leave them on the table, but if you don't have something you can't produce a finished item. So that's this formula. So again, if B14 ends up being a 1, then our logical upper limit is going to be whichever of these is smaller. Okay, and if it's a 0, then it's going to be, this whole problem is going to be 0. So we can go ahead and copy that, or finish that, and then copy and paste it all the way across. Our absolute values allow us to copy and paste. Now again, if you have the first one right, based on what you see in your textbook, but the rest of them are wrong, then you may have a problem with your absolute values. So absolute values only matter when you start copying and pasting a formula. They don't matter in the first one that you do. So if you see that in your problem, first thing looks right and then it gets kind of funny from there, then you probably have an issue with your absolute values. All right, let's move on. So the next thing we need to do is calculate the number of labor hours that are used to produce the unit. So again, this is another sum product formula, and we're going to grab our units produced, and that has to be the actual number of units produced, and we're going to multiply that by the number of labor hours needed to produce each unit. Oh, that's not what we wanted. There we go. Only one row there. Okay, and then copy and paste that, and again we're going to do another sum product, and let's see. Oh, and there's that sweet little voice. All right, now that he's taken care of, we are going to grab our units produced, and again we're going to grab the cloth needed to produce each type of unit, okay? And these are going to have to be less than or equal to the number, that's greater than, less than or equal to the amount that's actually available. There we go. All right. Now let's calculate our revenue. And again, this is going to be another sum product. And we're going to, again, grab the number of units that are actually produced as our first array. And our second array is going to be the selling price per unit. And if we make, no, you know what? You can make these apps, you can do some absolute values in here and copy and paste, but I'm just going to show you what to grab. So the next one, our variable cost, is again going to be a sum product with our units, number of units produced as the first array, and then the variable cost per unit. And again, remember what a sum product does, in case you can't remember, is that it is taking, in this case, it's going to take B16 times B9 plus C16 times C9 plus D16 times D9 plus E16 times E9 plus F16 times F9, and add all of those products together. All right, now our fixed cost for equipment. This is also going to be a sum product, but it is going to be with our binary constraints again, because again, you're either going to purchase this equipment or not purchase the equipment. So it's going to be either 0 or 1 multiplied by the fixed cost for the equipment. All right, and then our profit is going to be our revenue minus our variable costs minus our fixed costs for equipment. All right, now we are ready to put all of this in Solver. So we're going to go to Solver, and we are going to set our profit to a maximum by changing the two. Remember, we've got two ranges to grab here. So the first is B14 to F14. Oh, no, that went in the wrong spot, so I didn't change where I was looking. All right, so set objective B29 to max. And now I've clicked on the range by changing cells, and now we've got to select the range. There we go. Okay, now we've got to add in our constraints. So our first constraint is that the number of labor hours used has to be less than or equal to the number of labor hours available. Next constraint is that the amount of cloth used has to be less than or equal to the amount of cloth available. Our units produced has to be less than or equal to our logical upper limits. And so what this does is, again, it won't allow you to produce any units if the logical upper limit is 0. And then our final constraint here is that the equipment purchase is going to be binary. So either 0 or 1, you do it, or you don't do it. Go ahead and push OK. Make sure you're set on Simplex LP and solve. And this is indicating that our profit is going to be $54,614. So you are going to buy the equipment to produce shorts and jackets. You are not going to buy the equipment to produce shirts, pants, or skirts. You are going to produce 965.52 pairs of shorts and 379.31 jackets. Now, in some cases, you note that you can't really produce 0.31 of a jacket. But in this case, I wanted to show it to you how the book did it. If you were doing this in an actual simulation or an actual environment, you might want to consider an integer constraint for your units produced. And that might be something that you would consider putting in the write-up on this problem. All right, let's talk about how many of our resources we've used. So you have used all 4,000 labor hours and all 4,500 yards of cloth. Your total revenue is $80,345. Your variable cost, $22,931, and your fixed cost for the equipment is coming in at $2,800. Again, these are all things that you would want to put in your write-up. That's good information that your manager would want to justify your decision. All right, and let's look at sensitivity for it. Let's say that your manager wanted to see what the selling price of skirts would have to be in order to make it worthwhile to produce shorts, jackets, and skirts. So let's go to Solver Table, and we're going to run Solver Table. We're going to do a one-way table. And our input cell here is going to be the selling price of skirts. And our minimum value is going to be 70. Let's make our maximum value 140, and we will increase it. Oh, I did that wrong. 140 is the max. And then we're going to increase it by, sorry, having trouble here. All right, 140. And we are going to increase it in increments of 5. So our output cells are going to be the number of units produced. And we know if there's any units produced that we have bought the equipment. So we don't have to select that one too in this particular case, because we can infer whether or not the equipment was bought by whether or not there were any units produced. All right, and then the other one we're going to grab as an output cell is profit. Oh, and I've got to put back in again. Okay. There we go. Go ahead and push OK. All right. So let's look at what we have here. Our sensitivity analysis indicates that if a skirt sells for $85 or less, we are only going to purchase jackets and, let's see, what was C16? Jackets and shorts. At the point that a skirt sells for $90, we are only going to produce skirts, and we are going to produce 1,000 skirts, and we are not going to buy the equipment for shorts or for jackets anymore, and we are just going to buy the equipment for the skirts and produce the skirts. There are other ways that you could look at this. For instance, if your manager was going to specify that you had to produce at least 3 items for some reason, and you needed to put that constraint in there, you would do that by summing these, and then you would constrain that to be greater than or equal to 3. So we would have to go back in order to do that, we would have to go back to Solver. Then we would go ahead and add that constraint in there. So we would say that, oh, I didn't mean to change that. That should have gone into the constraint. Sorry, so let me put my profit back there. All right, and then I'm going to add a constraint that G14 has to be greater than or equal to 3. And greater than or equal to 3 would be, whether you pick greater than or equal would depend on whether your manager wanted exactly 3 or at least 3. All right, and so you see that we actually make less money in this scenario. And remember that that is what happens is that anytime you add constraints, you can never actually improve your model. It can stay the same, but it can never actually improve.